This was a simple example to demonstrate how we can calculate a timeline using the date and information function. Range names. Range names are simply names assigned to a range of cells in Microsoft Excel. Before getting into learning how to work with range names, let's understand why range names might be useful. For starters, range names can simply replace the cryptic formula references in a particular function with easy to understand names assigned to a particular range of cells. Let's say we had sales and cost. Now, if we assigned random figures, and let's say we have year 1, 2, 3, and cost is minus 40, minus 28, and minus 30. Now, let's say we need to compute year-wise gross profit or year-wise profit. What we might do is this plus this, and let's add up and let's add total. Now, as you can see, it's a very simple formula, but just looking from the function, one would not be able to tell what the sum function is trying to achieve here. Or from here, yes, obviously we can go back to the formula and trace what the formula is referring to. But what if we could say the formula would read something like sales minus cost? What if we could have a formula like this? Wouldn't it be easier to understand what the formula was doing? Range names are precisely used for that purpose and other. Resume. Range names are used for such purposes and more. For example, we might want to convert all accounting numbers in, let's say, rupees crores, and we then need to divide it by 10 to the power 7. Now we might go about dividing each number by 10 to the power 7, or just name a constant as crores and divide each number by crores. For the user as well and the reader, it would be easy to understand what that range name and what that function is trying to do. To illustrate, if we need to convert a number like, let's say, this into crores, we might go about saying this divided by 10 to the power 7, right? This is 2.89 crores. But what if we could have a formula like this divided by crore? One would easily understand that the function is trying to, or the formula is trying to convert that number into crores. So let's get into step by step how range names work and where they might be used. Let's delete all of this. Creating a name range is very simple. Let's say we have a date, 3rd Jan 2018, and we need to create a range name out of this. There are two ways to do it. One is we simply click on the name box here and say date 1. When we press enter, we successfully created our first range name. Now, if we want to refer this name, we press equal to date 1, press tab, enter, format this as a date, and let's format it in the same format. Now, as you can see, we have successfully created a name range out of this cell, which contains 3rd January 2018 as the date. Let's delete this. In the example before us, the example asks us to create a name sample_date for the following date from the name box on the formula bar. As we can see, this has already been done for us. So let's try it again. We go here, or let's try to replicate this result. We click on sample date, enter, let's paste the formula, the formatting, and as you can see, when we called up that name range, it gave us the same result, the date for that particular name range. Now let's look at the second example in defining names. The second example asks us to create a name for the following using left column as a selection. Now, one way to go about it is to go to each cell, the name box, and change the name. Well, we can do that, or we can use an Excel shortcut. Let's select the entire array and use the key combination of Ctrl plus Shift plus F3. The moment you click on Ctrl Shift F3, a dialog box will appear which prompts you to create names from the values in the top row, the left column, the bottom row, or the right column. Now, since in the present case we need to create names from the left column, we will tick on left column and press OK. Now you will see that the names have been created automatically. Now some of you may already have those names created in your Excel file. So let's start afresh and let's define some random numbers with the left column as the input for names. We say 10, 100, 1000, and here we enter 10, 100, 1000. Now as you can see, we need to create a name range for each of these numbers using this as a reference. So we select all of these, Ctrl Shift F3, left column, press OK, and when you place your cursor over each of these numbers, you'll see that the name ranges have automatically been created. Now if I say 10 and press enter, it will call the value 10, similarly for 100 and 1000. So remember the key, the shortcut is Ctrl plus Shift plus F3. Now let's take a step back and understand the name range window. Please press Ctrl plus F3. The moment you use that key combination, name manager window like this will open. Now let's go through each of the options. The new option gives you the option of creating a new name range. The edit option allows you to edit an existing name range. Delete, you can delete a name range. The filter option allows you to either filter name ranges based on names which are scoped to worksheet. Scoping we'll understand very shortly. Names scoped to workbook, names with errors, names without errors, defined names or table names. Let's understand scoping first. A name range might refer to a specific sheet or a specific workbook. When a name is is scoped to a specific sheet, it will only work in that particular sheet. Sheets with scope as global or workbook will work throughout the Excel workbook. Then names with errors. Names with errors means sometimes when we've created a name for a particular cell reference and we delete this row or column containing that cell reference, the name will show a ref error, which means that the name does not belong to any value now. Or it may so happen that the sheet was moved out of the Excel workbook and that name does not have any reference value. Defined names means all names created by the user, such as we are doing just and we did in the examples before. Table names refer to names which are created by Excel automatically whenever we are working with tables. Refers to means the cell reference to which the name refers to. So let's go to one of our own name ranges, which was, let's say, sample date. As you can see, sample date refers to cell in range name sheet B11, which is this cell. So this is the name manager. Going back to our example, we want to create a local name weekly for the following weekly dates using the name dialog box and then use it to calculate the month to which that week belongs to. So what we are going to do is, let's select all of these cells, press Ctrl F3, new, the name can be weekly. Before doing that, let's just delete the existing range name and delete. Now as you can see, there might be an error because there is no name for the above cell. So let's delete this as well. Now let's go back to our example. We select all the cells, press Ctrl plus F3 to open the name manager, new, name the range as weekly, and change the scope of this name to only this particular sheet, which is range name. Then we click OK. Now as you can see, there is a new range name weekly with all the dates, and it is only scoped to the current sheet. Let's put close. Now the formula asks us to create a local name weekly, which we have done, and then use it to calculate the month to which that week belongs to. So we use the function month and weekly, enter. We copy this formula for all the cells, and we have month for each of the dates above for which those dates belong to. Let's try using the same name range in another sheet. Let's go to this sheet is equal to, now as you can see, since we scoped that range name to that particular sheet, which was the range name sheet, there is no range name that is appearing in a different sheet, which is data validation. So that was the difference between a range name with sheet specific scope or a workbook scope. Going back to the range names sheet, let's look at the next part of understanding range names. Auditing names means we can view all the range names defined by us at once, so that in case we need to remove or edit any particular range name, or some range names which are not being used but were created and we want to remove them, we can view all of them at once. To do that, there is a very easy shortcut, which is F3. When you click on F3, it opens a dialog box saying paste name. Now, since we want to view all our name ranges, we simply click paste list, and you will see that it pastes all the name ranges defined by us in the particular workbook. Now we can go through each one of them to see whether the range reference is correct and whether the name is correct, or even whether we require that range name or not. That was all about range names. Hyperlinks. You might have come across hyperlinks while working on Microsoft Word, even if you have not. A hyperlink is nothing but a link to another cell, another worksheet, a web page. It can be another document. Let's see a simple example of how we can create a hyperlink to move from one sheet to another. Let's say I have a new workbook wherein on sheet 2 I have certain calculations, let's say of marks of students. I will have names, marks, and so on. However, I want to link this section and create a hyperlink out of this section in sheet 1. So let's say we go back to sheet 1. We say student marks. Now we need to create a hyperlink out of this. We'll go to insert, hyperlink. Here we can already see there are 4 options. Existing file or web page gives you the option of creating a hyperlink to a different file or a web page. Place in this document allows you to create a hyperlink within the workbook. This gives you the option to create a new workbook. The hyperlink will create a new workbook. And this gives you the option of creating a hyperlink to a particular email address. Let's go back to the second option placed in this document. Now, if you need to create a hyperlink within the particular sheet, which is sheet 1, then you can manually type any cell reference here. Or if you want to create a sheet reference or a different sheet reference, then you can choose from the options below, which is you can refer it to sheet 1, sheet 2, sheet 3. If you select sheet 2, a hyperlink will be automatically created for the first cell of sheet 2, which is A1. So let's, for ease and understanding, just click on sheet 2 and press OK. Now you will see student marks has been highlighted as blue font and underlined, which signifies that it has become a hyperlink. Now if we click on this, the hyperlink will take us to sheet 2. That is how we can create a hyperlink. Data validation. Data validation can be used to restrict the type of data or the values that users can input in cells. Normally, data validation is also used for creating a drop-down list. Before getting into the examples, let's directly jump into the data validation dialog box. To access the data validation dialog box, go to Data tab and select Data Validation. Data validation dialog box looks something like this, where we have settings on the first tab, input message on the second tab, and error alert on the third tab. Let's go back to settings. Under settings, you can see validation criteria, which says allow is the first option and data is the second option. Now let's click on the drop down for allow. You can see 1, 2, 3, 4, 5, 6, 7 options for allowing, or the validation criteria for allowing the type of values that can be input. A whole number will only allow you to input whole numbers. Decimal will allow you values which include decimals. A list can be a range of cells, manually input numbers, or a name range which is represented by a range of cells. Date will be specific and restricted to a date. Time again. Text length will be the number of characters you can have in that particular cell, and custom can be a formula. So let's go back to the data validation dialog box. If we select a whole number, the data option becomes accessible, where then we have a variety of options to restrict further the data that can be input in a particular cell, which is between, not between, equal to. So any value we put here, let's say 1 to 5, and we click OK, the user will not be able to enter any value other than 1 to 5. Let's try that out. If I input 6, Excel will prompt me that the value entered by me is not valid. Why? Because as per data validation, I have restricted that cell input to only values between 1 to 5 being whole numbers. So even if I enter like 1.5, the same error will pop up. Let's go back to the data validation dialog box, and let's say we want to remove all the data validation. Simply press clear all and we revert to the default option. The next tab, input message, is the input message when we hover our mouse or select the cell which contains data validation. So we can include, let's revert our validation to say 1 to 5, and input message can be enter a number, or rather enter a whole number from 1 to 5. Let's press OK. Now if we go to this cell, you'll see that the cell automatically gives us a message, enter whole number from 1 to 5. Let's create a border for this cell so that we know that this is the cell we're working on. Now let's go back to the data validation dialog box and look at the third tab, which is error alert. When this error alert is checked, this checkbox is ticked, it will always give us that error whenever we enter a value which is outside the range of data validation, outside the range specified for data validation. Now we can also change the way the error is prompted. We can have it as a warning, or we can have it as an information bar. Whenever it is stop, it will give us 3 options. Let's see what. Let's say it will give us 3 options: retry, cancel, and help. If we change that to a warning, let's try again. It will let me change the value, but again it will give it with a warning. So the value entered is not valid. A user has restricted values that can be entered into this cell. Continue, yes, no, and cancel. And the third option that we saw was an information. So if we input 6, it will be a simple confirmation that a value entered by you is not valid, and if you click OK, it will nonetheless accept that value which is outside the range. Let's go back to the data validation option, error alert. So you can specify what the title and the error message should be for each of the options, either being stop, warning, or information. Let's clear everything out and press OK, and then delete this cell and remove the formatting as well. And go back to the first example for data validation. The first example before us asks us to create an input cell for product selection with a data validation on product names to be taken from a list of qualified products only. So let's say we wanted to create a data list. Now let's look at data validation examples. The first example before us asks us to create an input cell for product selection with a data validation on product names to be taken from a list of qualified products only. Let's develop a new data validation list here. Just let's copy the formatting, Ctrl-Alt-V, G. Alright, now let's go to the data validation option, settings. Now from all of the options we can see list is something that would solve our purpose. We click on the source button, select all of the items and select all of the items and click OK. As you can see, we will have a list of all of the items here. As you might have noticed, instead of referencing the entire list, we can also create a name range out of that list and refer that particular name range as a list option. So, to explain, if we select all these cells, we will see that the list has been already named as products. If we go back to the data validation option and simply replace this cell reference, this range reference with products and click OK, we will get the same list here. So let's try it in another cell. We go to data validation, click on list, source is equal to products, click OK, and you can see that we have a drop down with all of the items contained within the name range defined by the list of products. Let's move on to the next example, dynamic data validation. The next example is dynamic data validation. The example asks us to create a data validation on COGS, which stands for cost of goods sold inputs, such that gross margin should be always be greater than or equal to 0%. Then also display a warning message on incorrect data entry. What the example means is, let's say we have sample entries here. $300, $400, $150, and $50. Now, we should be entering COGS in such a way that the gross margin does not fall below 0%. How can we do that? First, let's create the formula for gross margin for this particular column, which is equal to sales minus COGS, which gives us the gross profit, divided by sales. Format it into percentage and add new decimal. We can also edit this formula by replacing G27 by 1 and say 1 minus G35 by G27. Now, we need to apply data validation in these cells in such a way that whenever my COGS is greater than revenue for a particular product category, it will show up an error message. So let's see what kind of error message we want to present by testing the solution first. Let's say we put a COGS of 8,000 here. Now the error message is gross margin cannot be less than 0%. Continue? Let's say yes. Now the moment we continue with this input, we can see that the gross margin for hair care product is minus 8.8% because the COGS 8,000 is more than the revenue. Now let's try to remodel and apply such a data validation in our own input. We select all the cells, go to data, data validation. Here in the custom option, we click on formula and say is equal to first cell should not be less than, should be greater than, equal to 0. Let's press OK. Now, if we put 600, we will have an error. However, if you put 500, we can, or if you put 400, data validation will allow us to input that figure. Let's go back to the data validation option and see what we did. We selected allow and chose custom. Custom means that we can input a formula as a data validation criteria. In the formula, we said G43, which is gross margin for hair care, to be greater than or equal to 0. But if you remember, we selected all these cells and then clicked on data validation and then applied this formula. What Excel does is, in case this is a relative reference, that is without any dollar signs, data validation for the subsequent cells, which is for soaps and detergents and so on, will automatically change to the respective cell references in gross margin. So to illustrate, if we look at data validation for soaps and detergents, we'll see that the value has changed from G43 to G44. Similarly, for skincare products, data validation has changed from G44 to G45. This is called dynamic data validation, where each cell is being evaluated for valid input entry depending on the formula which was entered as a relative reference. Now let's look at the second part. The second part was to display an error message. Now, as we've already seen, we wanted the style to be a warning and the error, let's just look at the error which we did get here. Gross margin cannot be less than 0%, and the title was invalid COGS. So let's replicate that here. Warning, invalid COGS, gross margin cannot be less than 0%. Okay, now let's test this by putting 600. And we have the same error message as we had in the solution example. If you say yes, we get a negative 20% of gross margin. And let's just put random figures here so that we can calculate gross margin for all the products. And there we go. We have successfully used data validation to create an error message whenever the gross margin is negative for COGS. Data tables. Let's understand the concept of a data table first. Let's say we have a simple example of certain quantity of product to be sold, the rate of that particular product. Let that product be water bottles. So the revenue from the water bottles will be quantity sold into rate. Now let's capture that information over here. Water bottles, quantity, rate, revenue. Okay, let's say 200 units at ₹20 each will give me a revenue of 200 into 20, which is quantity into rate. Easy. What if I want to evaluate how will this revenue move if my rate keeps changing? Or how will my revenue move if my quantity keeps changing? Now, one way to go about it is, let's say I keep the quantity constant, I change the quantity and keep the rate constant. And the second is I keep the quantity constant and change the rate. I copy the formula from above. Fair enough. I have an analysis in front of me to see what are the revenue changes when my quantity changes or rate changes. However, there is a better way to present this information, and that way is through a data table. What a data table does is, it takes away the need of recomputing the revenue or any calculation for that matter every time. It asks for three basic inputs. One is to link a calculation, such as revenue in this case. The second, to capture the change in one of the variables that is affecting that calculation. So let's say in this case it was quantity and the rate. It can be either quantity or rate or both even. So there are two kinds of data tables. One is a one-way data table and another is a two-way data table. A one-way data table, as you can guess, is to evaluate the change or impact on a particular calculation only when one variable is moved. A two-way data table, on the other hand, allows you to view the changes or impact on a particular calculation when two variables are moved. The example we just created would necessitate a two-way data table. Now let's see in the example before us how that data table gets us the desired result of evaluating revenues at different quantities and rates. As you can see in the example, the quantity sold is given in kgs, which is 3500. The rate is rupees per kg, which is 1200. Let's ignore EBITDA margin for a moment. Let's ignore volume sensitivity and rate sensitivity also for a moment. We look at the calculation in this small table where revenue is equal to rate, revenue is equal to quantity sold, rate, so quantity sold, which is F14, rate, which is 1200, and divided by 10 to the power 6 to convert it into rupees million. Let's just change this to kgs so that you don't get confused. Now, ignore the EBITDA margin again for a moment. Let's come to the data table below. As you can see, the columns represent change in quantity sold. So let's rename it as quantity sold. Okay. And let's rename the rows represent change in prices. So let's rename this as prices. Okay. Now, as you can see, when my quantity sold is 3000 and the price is 800, the revenue will be 2.4 million rupees. Similarly, when the quantity sold increases but the rate remains the same, my revenue keeps on increasing. This is a two-way data table where I can evaluate revenue at various levels. Now let's try to replicate that table using the data tables option, the data tables command in Excel. Let's scroll a bit to the right and create a fresh data table from column N. The starting point of creating a data table should be to first link the desired calculation or output which you want as a result or as different scenarios. So, like you can see in this data table, H14, which was the calculation for revenue, was linked. It is necessary that the calculation must be linked and not pasted as a value, because the data table will automatically determine what the logic is between the rows, the specified columns, which is quantity sold, and specified rows in this calculation, which is H14, and automatically populate these results. So, as a starting point in column M, let's first link the calculation for revenue. Done. Now, let's select a data table for so many scenarios. Or before that, just for ease of reference, let's create how many columns do we have? 5 versus 5, alright? So we have 5 columns here, 1, 2, 3, 4, 5, 2, 3, 4, 5. We say quantity sold. We merge these cells and let's put a border around these so that we know, and here as well. Put a border, we merge, and we say prices. Okay. Here, let's put random quantity sold, or just copy these quantities for now as values. Similarly, these prices as values. Done. We have set up the initial data table. Now we want this data table with results over here. So let's select the entire matrix of the data table. Let's just edit it to exclude the extra cell. Okay, now we select the matrix. Now go to data, what if analysis, and data table. You will see a dialog box with two inputs to be given to the dialog box. One is the row input cell and other is the column input cell. The row input cell refers to these rows, which are the prices, and the column input cell refers to these columns, which are the quantities sold. Now, since the rows contain all the prices, the row input cell should be linked to the calculated amount, which is the price which is being used as an input to the main calculation. So we can see that 1200 here is being used to compute the revenue which we have linked here, right? So we'll have to link this as a row input cell. Similarly, for the column input cell, since we know that these columns contain the quantities and 3500 in cell F14 is the input for quantity sold for calculation of revenue, here we give F14 as the column input cell. Let's press OK, and you will see the moment you press OK, we have a set of various revenue figures populated for each of the quantities sold and prices at different levels. Now let's make some small adjustments. First, let's copy this entire table and paste special only the formats. Okay. Now, as you must have noticed, 4.2 in this table was highlighted in a different color. Can you imagine why is that? It is because conditional formatting has been applied to this particular table to say whenever the total revenue result in the data table equals to the actual revenue computed in H14, then color it in a particular way. So let's go and just view the conditional formatting. We go to conditional formatting in the Home tab in Manage Rules, and we can see that conditional formatting has been applied. When we click on Edit rule, we'll see format only cells with cell value equal to $14, $H14, and with the color of blue, which is specified in the Fill tab. We can change the color to, let's say, this, press OK, press OK, OK, and you will see the color has changed. That was the first minor adjustment we needed to make in our data table. The second adjustment, as you might see in the solution, is that these figures, the changes in quantity sold and the prices and changes in prices, have been linked to a predetermined sensitivity or a predetermined change for each of the parameters. What that essentially means is my actual quantity sold was 3500, so I want to evaluate two cases above 3500, two cases below 3500 for a difference of 250 kgs. Similarly, for rate, I calculated my actual revenue at 1200 rupees per kg, but I want to evaluate it at 200 rupees and 200 rupees above for two cases and 200 rupees consecutively below 1200. So if you see here, what we can do is we can manually link 3500, and then this can be is equal to this minus 250 kgs F4. We fix it, and this too, we can copy this cell here. Okay. Another point to remember, all these cells, the ones that are changes in our key variables, should only be either hard-coded values or linked to a cell which is not part of the main calculation. So this 3500 cannot be a link to this calculation. However, it can be a link to this calculation. Sorry, this input cell. So let's change that and link it with this. Similarly, we add 250 to the cells to the right of 3500 and do the same adjustment for prices, where we link the price to this input cell and is equal to 1200 minus the change in price, and copy this formula here, and down below we say is equal to 1200 plus change in price, F4, enter, and copy this. So now you can see that we have a two-way data table. We have linked the variables to the main inputs and the change in the main inputs by the change specified in the example, linked the main output to the first cell of the data table, applied conditional formatting wherever the sensitivity or wherever the scenarios meet the main or the actual calculation of revenue, and that is how we arrived at our two-way data table. Now let's look at a one-way data table. A one-way data table here simply evaluates revenue and EBITDA margin basis the prices. Let's go back to our calculation where we ignored EBITDA margin. EBITDA margin is nothing but the gross, which is expressed as a percentage of total sales, which has been hard-coded as an input here. So EBITDA margin expressed in rupees million will be 25% of the total revenue, which comes out to 1.1 million rupees. If we look at the one-way data table here, revenue has been linked from cell H14 and EBITDA margin has been linked from H15. Now we want to evaluate different revenue and different EBITDA margins for various price levels. So what we do is, let's replicate this table here. I'm copying only the formats. Let's link the revenue and the EBITDA margin. Let's rename them revenue, EBITDA margin. Here let's copy paste these values. Okay. Select these, go to data, data tables. Now, as we learned in a two-way data table, for items in the rows, we will specify row input cell, and items in the columns, we will specify a column input cell. In a one-way data table, we'll have to think as we'll have to inverse the rule applicable. So in this case, we will have to input the column input cell, which is price, enter, click OK. We can see the revenue at various price levels. Now for EBITDA margin, as you can see, EBITDA is being calculated as 25% of the total revenue. So we select both of these columns, go to data validation, data table. Again, in the column input cell, we select the revenue as the column input cell and click OK. And you can see EBITDA margin for various revenue levels is being computed. This is how a one-way data table is created. We can create a similar data table with the changes in quantity sold and revenue and EBITDA one below the other. This was how data tables work. Now let's look at goal-seek. To understand the concept of goal-seek, let's take a small example. Let's say quantity sold is 100. The rate is undefined, and the sales, which is equal to quantity sold into rate, is also 0. Now, what if target sales are 500? So the question we need to ask is, what should be the rate so that my sales are equal to 500? Now, since this being a very simple maths problem, we can say the rate is 5, so that we get the sales as 500. However, as and when the problems become more complex, and it is not about a simple algebraic solution, we often resort to goal-seek. Goal-seek allows us to calculate certain variables based on the required output. Let's see how goal-seek solves the problem at hand. We go to data, what if analysis, goal-seek. The first argument is set cell. Set cell means the output or the target output which we're trying to achieve. So we say set cell sales to value. We know that we need to set the sales at 500. So we input 500 by changing cell. Now this means that we need to specify a variable which will impact that calculation. In this case, it is the rate. So we select the rate, J11, and click OK. The moment we do that, goal-seek quickly runs a number of calculations and arrives as a solution at 5, the rate. Very simply, this is what goal-seek does. Now let's look at a complex problem where goal-seek might help us. In this example before us, the question is, with the help of goal-seek, compute maximum account payables to keep in books so that current ratio is 1. Current ratio in this calculation, as you can see in cell F20, has been calculated as the sum of current assets divided by account payable. Now, let's remove or let's change the value of account payables to 200. Now, as you can see, the current ratio has moved from 1 to 3.2. Now, we need to get back to the desired current ratio of 1. So, let's run goal-seek again. We go to what if analysis, goal-seek, set cell F20 correct to value 1. By changing cell, account payables is the cell we want to change. We select account payables and click on OK. Goal-seek again runs quickly and changes the value of account payables so that the current ratio is set to 1 again. This was goal-seek.